Okay, so next I want to start implementing some, like a group of logical instructions. So for example, we'll have AND, OR, XOR, test, maybe not and negate as well. So if we go to the arithmetic tests and create a copy of this called logical, and then just go and have a look at, let's say, AND first. So AND here is actually the same as add, it's just that it's got some different opcodes and a different opcode extension here. So if we just keep the add test cases and rename them to AND instead, then we can use NASM to generate the listings for this. So this is a CodeGen x86 test data logical. And we'll create a listing for CodeGen x86 test data logical.lst. So now if I go to the encoder test, I can basically just take, let's see, we've got down to op add here. I can just take this and put it on the end here. And then we'll just call this logical, and we'll change all these op adds into op and instead. So if I run the go test now, we don't have op and, so let's go to op add, and we'll add those down. Maybe I'll just keep them up here or something. So we'll say and, let's run the tests. Okay, so now we don't match any forms, so we'll go to the forms. And we'll add some forms for op and. So we'll keep all of the add ones since it's the same, but it will fail because I've got the wrong opcode extension for these ones, and I've got the wrong opcodes for the other ones. So let's just do the opcodes first. So in these cases where we've got the A register special cases, these are 24 and 25. Then we've got 80 and 81 and 83. These are all the opcode extension ones, but now they're going to be using opcode extension 4. Then we've got the special case. The special cases are also just opcode extension 4, and then the other cases are 20 to 23. So this is 20, and this one is 21, 22, and 23. So let's try running these again. Okay, so that passes. Now let's go and implement OR. OR is here. And this, again, is the same thing, but we've got a different opcode extension and some different opcodes here. So let's just go and go to logical.asm. We'll copy and change all of these to OR. Regenerate the listing. Let's go to encoder test. And actually, if I go to the consts for a second, we'll have OR. We're going to do XOR, possibly test, not, and negate as well. So let's just create a copy of all of these. So these will be OR, but otherwise they are the same. So let's do a go test. Okay, so no matching forms. We'll do a copy of AND in this case. So this becomes op OR. Now we get incorrect results. Let's change the opcode extension from 4 to 1 for these ones here. And then we've got 0C and 0D. So 0C here and 0D here. And then the other opcodes are 8 to B. So here we've got 08, we've got 09, 0A, and 0B. Okay, so that's OR. Let's go have a look at XOR next. XOR it looks like it's just more of the same. So again, different opcode extension, different opcodes. So we'll just go to logical ASM, take another copy of the ORs. Oh. Let's see. Okay, let's change all of these to XOR. Oh. Okay, XOR. Regenerate the listing. Encoder test, we'll go and copy all of these OR tests. Change them to XOR. Go test should match no forms. We go to forms. We'll add XOR forms. This should now fail with incorrect bytes. So now we need to change these to opcode-extension 6. And then the opcodes that we've got are 3435, 35, and then we've got, so these ones are opcode extensions, those are fine. And then we've got 30 to 33. So we've got 30 here, 31 here, 32, and then 33. Okay, that's fine. So now let's go and have a look at test, I think. So test is a bit different, but not that much different. I think it's just the 8-bit immediates don't have a special case here. So let's just go and take the same XOR tests. We'll change this into test, and then I think that we just don't have these immediate 8 special cases, basically. So let's see if NASM is okay. Yep, that's fine. Back to encoder test, we'll go copy these XORs. So let's change all of these to test. Then we'll get rid of the byte optimization tests. Okay, so this should match no forms again. That's fine. Form. Okay, let's go to copy XOR here. So we don't have this immediate 8 optimization, but other than that, I think it's all the same. So we've got 8 A here, or sorry, A8, A9. Then we've got, so this is F6 with an opcode extension of 0 now. So this is 0, and then we've got F6 and F7. And then for the other ones, we've got, well, actually, we've only got RM R8 here. Let me just go back and look at these tests again. Okay, I guess that these must be just doing the same test as these, is my assumption. So let's just go to look at the logical listing. Yeah, so this is just, the test is the same either way, so these just get flipped. There's no point in having another form for this because this is the same as this, so they get encoded with the same bytes here. So let's just, okay, back to the forms again. So we don't actually need register as being its own op1. We don't need the operand encoding RM. We just need MR, as far as I can see. So these ones are 8.4 and 8.5. So we've got 8.4 here, and we've got 8.5. And this one really, so I think this will not match forms based on the way that based on the way that I'm trying to omit these with the same operands. But if I do op2 as reg or memory, then it matches all of them. And in this case, what I actually want to do is have them swap around. Actually, I think if I just keep those, okay, let's just do it like this. So if I keep these forms around for matching, and just do it this way. Let's see, we'll do. Oh, this is MR, this should be RM. Okay, there we go. So even though the operands are flipped around, I could just match them in the way that I usually do and just output the same opcode. Okay, so that's test. Then we'll go to, let's say we'll do not next, because that's the one that I put in the list of the consts after test. So this is a pretty simple one. This is basically the same as like mul or div or something. So let's just go to the arithmetic ones and go to mul, maybe. So let's just take these mul tests, because it's just RM. Yeah, single operand RM. So we want a logical ASM. Get down to the bottom here, we'll do mul, and we'll just change this into not. Okay. Then we'll go to the encoder test, and let's just do op mul. We'll just take these tests here and put them down in the logical listing tests. So these ones become not. Okay, so again, we should match on no forms. Yep, then we go to forms, we'll copy the op mul ones this time and put them below test. This can be op not. So these are actually still F6 and F7, they just have a different opcode extension. So if I do this test, we get output but the incorrect bytes. So if this becomes 2, now they pass. And then finally we've got a negate here, which is the same thing again, but it's opcode extension 3. So let's just quickly add those. We've got logical ASM, we've got not. We'll just do a copy of these. This can change into neg. Regenerate the listing again, and we'll go back to the tests and just copy these to make them neg instead. So we've got neg here. This should now be incorrect. Oh, yeah, still got to do the forms. So we've got neg in this case. And now if I change these to opcode extension 3, now they pass. So that is the basic logical group that I wanted to get out of the way. There is something else that I just want to clean up, which is that I don't really like the way that I'm naming these, particularly in the cases of imul and idiv. It's sort of, you know, should this be uppercase or lowercase sort of thing. It's a small thing, but it's bothering me, so I'm just going to change these all to uppercase so that they match what's in the Intel manuals, and then I don't need to worry about which way it is. So we'll just change all of those. So let's look for op mov. So we want to look for all of the op things in here and just uppercase all of those. So have a look, another look for op mov here. And then we've got them in these tables here as well. So let's just get, oh, not those ones. Let's see, is there any others in here? Okay, I think it's just these. All right, let's just do these ones. Okay, we'll retest this. Okay, that's all fine. I guess it's cached test because technically the source hasn't actually changed. Let me just do C4 here or something. Okay, so that's wrong now, and then if I do C3, that's a cache test. Maybe I can, is it go mod clean test cache? Okay, yeah, all right, that's better. Okay, so that's the group of logical instructions out the way.